students. I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SNIT. Today we are going to discuss about heat exchanger and their classification. Okay. First of all, what is a heat exchanger? A heat exchanger is a device used to transfer heat energy from a hot fluid to a cold fluid. That is, by using a heat exchanger, a hot fluid can be cooled or a cold fluid can be heated. For example, consider a boiler in which the cold water is heated by flue gases. Here, the heat energy of the flue gas is transferred to the cold water by using a heat exchanger, which is called as boiler. Another example is the radiator used in an automobile. Here, the heat energy from the cooling water is transferred to the atmospheric air by a heat exchanger, which is called as radiator. Okay. Various examples of heat exchangers are evaporator, condenser, boiler, heater, radiator, etc. Okay. Next, classification of heat exchanger. Heat exchangers can be classified on the following basis. First one, based on nature of heat exchange process. Based on nature of heat exchange process, heat exchangers can be classified into two types. They are first one another direct contact or open heat exchangers. Second one, indirect contact heat exchangers. Indirect contact heat exchangers can be again classified into two types. They are first regenerative type heat exchangers. Second one, Recuperator type heat exchanger. The second basis for classification of heat exchanger is direction of fluid flow. According to the direction of fluid flow, heat exchangers can be classified into three. They are parallel flow heat exchangers, counter flow heat exchangers, the third one is cross flow heat exchangers. The third basis for classification of heat exchanger is design. That is, according to the design, heat exchangers can be classified into four. They are concentric tube heat exchangers, single pass shell and tube heat exchangers, multipass shell and tube heat exchangers, and compact heat exchangers. The fourth basis for the classification of heat exchangers is according to physical state of the fluids. That is, according to the physical state of the fluid, heat exchangers can be classified into two. They are condenser and second one is evaporator. All these types of heat exchangers are explained one by one. The first one is direct contact or open heat exchangers. In an open heat exchanger, both hot fluid and cold fluid are mixed together to transfer heat. In this diagram, steam enters the heat exchanger through the pipe in the left bottom side and leaves us warm water through the pipe at the top right side. And cold water enters the heat exchanger through the pipe which is at the right side bottom and leaves us hot water through the pipe which is at the top left side. Thus, the heat energy from the hot steam is transferred to the cold water by mixing them. That is, here, the heat energy from the hot fluid is transferred to the cold fluid by mixing. Examples of open type heat exchangers are cooling towers, jet condensers, direct contact feed water heaters, etc. The next type is indirect contact type heat exchanger. The first type is regenerator type heat exchanger. This is a diagram. Here the hot fluid is passed through a certain medium which is called as matrix. Thus the matrices get heated by the hot fluid. Then the cold fluid is allowed to pass through the heated matrix. Thus, the heat from the matrix is transferred to the cold fluid. Here, the matrix, which is called as regenerator, stores the heat removed from the hot fluid and transfers it to the cold fluid. They are mainly used in IC engines and gas turbines. This is the diagram for regenerator, but in this diagram you cannot see that matrix. Okay, matrix is inside this regenerator. The second type is a recuperator type heat exchanger. Here the hot and the cold fluids are separated by a separating valve. In this type, there is no mixing of fluids. There are three modes of heat transfer. They are convection heat transfer from hot fluid to the separating valve. Second one, conduction heat transfer from one side of the valve to the other side. Third one, convection heat transfer from the valve to the cold fluid. Examples are economizer, superheater and air preheater. Okay. In this diagram, you can see the separating valve which separates the hot and cold fluid. Okay. The next type is parallel flow heat exchanger. In a parallel flow heat exchanger, both hot fluids and cold fluid passes through the heat exchanger in the same direction. That is, both hot and cold fluids enters the heat exchanger from the same side, flows in the same direction and leaves from the same side. The flow of both the fluids are represented by arrows in the diagram. In the diagram, you can see arrows which represents the flow of hot and cold fluid. Here the cold fluid flows through the inner side and which is shaded, and the hot fluid flows around that. Next, counterflow heat exchanger. Here the hot and cold fluid enters the heat exchanger unit at opposite ends. They flows in opposite directions, and also both the fluids leaves at opposite ends. The peculiarity of counterflow heat exchanger is that they gives the maximum heat transfer rate, and thus this type of heat exchanger are commonly used. Here you can see that the cold fluid enters the heat exchanger from the right side and leaves through the left side. That is represented by an arrow, and the portion is shaded. But the hot fluid enters the heat exchanger from the left side and leaves through the right side. That is also represented by arrows from left to right. Okay. Another type of heat exchanger is the concentric tube heat exchanger. Here two concentric tubes are there. That is, one tube is placed exactly center to the other fluid. That is, one tube is placed inside the other one. One of the tube contains the hot fluids and the other tube contains the cold fluid. This is a diagram. In this diagram, you can see that one tube is kept inside the other, and a heat exchange process is happening. The next type is shell and tube, single pass shell and tube heat exchanger. Here, one of the fluid is flowing through a bundle of tubes which are enclosed by a shell. The other fluid is flowing through the shell and it flows over the outside surface of the tubes touching them. Here you can see that the tube is placed inside a shell in which this one of the fluids can flow, and inside the tube itself another fluid will flow. There are baffles or baffle plates provided which enables the motion of the shell side fluid in a slow manner, which enhances the heat transfer. The next type is multipass shell and tube heat exchanger. In this type, two shells are provided and there are four tubes. In the diagram you can see it clearly. Here, if the fluid is flowing through the heat exchanger only once, then it is called as single pass, and if the fluid flow through the heat exchanger more than once, then it is known as multi-pass. Here, baffle plates are provided within the shell to make the shell side fluid moves forward and backward from one end of the shell to the other. The next type is compact heat exchanger. As the name implies, this type of heat exchanger are generally small in size and thus they can be easily transported. They are commonly used for some special industrial applications. The main advantage is simplicity in size and less weight, and thus they can be easily transported from one place to another. This is the diagram for a compact heat exchanger. Next type is condenser. In a condenser, the temperature of the hot condensing fluid remains constant and the temperature of the cold fluid is increased from inlet to outlet. In this diagram, the constant temperature of the hot condensing fluid is represented by a horizontal straight line and the increase in temperature of the cold fluid is represented by a slanting line from left to the right. Here the latent heat released by the hot fluid is equal to the heat absorbed by the cold fluid. The condensers are mainly used in our AC system, that is air conditioning systems, or fridges, that is refrigerating unit, etc. The last type of heat exchanger we are going to discuss is evaporator. In an evaporator, the temperature of the cold fluid remains constant, but this cold fluid vaporizes into steam by absorbing latent heat from the hot fluid. That is, here evaporation of cold fluid takes place, and also the temperature of hot fluid gets decreased. Here the latent heat absorbed by the cold fluid is equal to the latent heat lost by the hot fluid. We can see evaporators in our air conditioning units. Large evaporators can also be seen in various industries, etc. That's all about this slide. Thank you.